Hi kids, welcome back to Common Core Algebra II. Today's lesson 6.11, the locus definition of a parabola. My apologies that the audio didn't work on the first video, so hopefully it will pick up on this one. So we talked the other day about the locus definition of a circle, which is pretty easy. It's just all the points that are equidistant from a given point, which we call the center, of course. And that distance that we talk about is the radius. The locus definition of a parabola is a little bit more complicated. So the parabola is a collection of all points equidistant from a fixed point that we call the focus and a fixed line we call the directrix. All right, so we'll show a little bit more with our example in number 1. Hopefully this will make things a little clearer. So the parabola, y equals, you know me, I always like to box in my math, is shown graph below with the selected points shown. For this parabola, its focus is the point 0, 2, and it shows it right here on the graph, and it says focus. All right, and the directrix is actually going to be the y-axis. That won't happen all the time, but this time it is. Oops, sorry for the interruption.
Thank you.
All right, so how far is the turning point, 0, 1, from both the focus and the directrix? All right, so the turning point is this point right here, which is halfway between the directrix and the focus. And that point there, as you can see, is 1 unit from the focus and 1 unit from the directrix. So we're going to say 0, 1 is 1 unit from both the focus and directrix. The second question says, how far is the point 2, 2 from both? Well, it's nice that they picked these nice points because, you know, this is a vertical distance. So we know it's 2 units from the focus and 2 units from the directrix. So we're going to say here that 2, 2 is 2 units from both the focus and the directrix. Notice how I use the wording from the problem. I don't try and create new words. I use the wording from the problem to help me explain my answer. So B says, use the distance formula to verify that the point 4, 5 is the same distance away from the focus and the directrix. Okay, so draw the line segments from the focus and the directrix. Oh, I need to put up a little bit so I can get to that point. All right, so consider that point. Let's use red this time so we can see it. So now this, from this point to the directrix, is a vertical distance. So that's pretty easy. That's going to be 1, 2, 3, 4, 5. So this unit is 5. But from here to here is not quite as obvious. Although if you remember from your geometry, this is a 3, 4, 5 right triangle. So you could use the Pythagorean theorem here to show that, but our problem says to use the distance formula. So the distance formula, if you remember what the formula is, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance is equal to, let me write down my 2 points that I'm considering here. So the first point, let's put it over here, is going to be 0, 2. And the other point is going to be 4, 5. So it's going to be square root of 4 minus 0. It doesn't matter which one you start with, as long as you start both of them with the same one, and 5 minus 2 squared. So D is equal to the square root of 16 plus 9, which is the square root of 25, which is 5. So you can see, you just verified that it is the same distance away. And then it says to do the same thing for the point 6, 10 up at the top. So we know our 2 points are 6, 10 And our focus, again, is 0, 2. So the distance formula here is going to be the square root of, now again, it doesn't matter where you start. We can do 6 minus 0 squared plus 10 minus 2 squared, which is equal to the square root of 36, because 6 minus 0 is 6 squared is 36, plus 10 minus 2 is 8 squared is 64. So this is equal to the square root of 100, which is equal to 10. Now let's just check our vertical distance here. So the point that I just did is the distance from here to here is 10, and the distance from here to here is the vertical distance of 10. So we just showed that that point is equidistant from both the focus and the directrix. All right, so pause, write down what you need to before we move on to exercise 2. So the algebra of finding the equation of a parabola based on its focus and directrix can be challenging, but you know all of it from previous work that you've done. All right, so exercise 2 says consider a parabola whose focus is the point 0, 7. All right, so they give you a sketch here. It says sketch a diagram, and it says the directrix is the line y equals 3. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and actually we don't even need so much going this way because we don't have any x values to consider. So the point 0, 7 is 1, 2, 3, 4, 5, 6, 7. So that's our focus. That's our focus at 0, 7. And the directrix is right here at y equals 3. So now, the first thing we need to sketch this is determine what is our vertex. What's our turning point? Well, I'll tell you this, that with the focus being on the top and the directrix being on the bottom, the parabola will never cross the directrix. All right, it wraps around the focus. So I know this particular one is going to open up. All right, so and I know the vertex has to be halfway between the directrix and the focus. All right, and because the focus is rather close, it's going to be a little bit of a wider parabola. The further it gets away, the skinnier it gets. All right, now this probably isn't even perfect either, but at least it's not too bad. But you don't have to worry about it being drawn to scale. So that's what it looks like. We did the turning point. We didn't identify the turning point. We should do that the same way we did the focus. So the vertex is 1, 2, 3, 4, 5, so 0, 5. Now it says determine the equation of the parabola using the locus definition. Now, the locus definition basically says that the distance from any point to the directrix has to be the same as the distance from the focus to that point. So let's pick a point. How about this point right here? And we're just going to call it xy. Now, what they're saying is the distance. Now, I should use a different color. I'm kind of running out of colors here. Oh, I can add a couple. How about purple? So the distance from here to here has to be the same as the distance from here to here. Remember, that's a perpendicular line. All right, so I'm not bad. That looks pretty good. All right, but what do we know? Do we know the horizontal distance? I'm sorry, the vertical distance. And that one isn't so bad to figure out, because if you figure out that y, my y here that's represented on my point, goes from here all the way down to here. So I know that's y. So how am I going to represent this? Well, I know this is 3, unit 3, because I've got 3 units above the y-axis is my directrix. So I'm going to be able to represent my vertical distance as y minus 3. All right? Take a minute and think about that for a second before we move on. All right? So one more time. I know my distance from This point down to this whole thing here is my y. That's y. That's this y right here. All right? So, but I need to know what it's going to be from here, from this point to here. So what I did here is I took out these 3 units and I represented it right here. So y minus 3 is going to be my vertical distance. So now let's try and put that together using our distance formula, because I know that the distance from my focus to my point, x comma y, is going to equal the vertical distance. So I know that y minus 3 is equal to the square root. Now remember your 2 points. Your first point is xy, which I always make xy. My second point is going to be my focus, which is 0, 7. So I'm going to have x minus 0 squared. We'll put the whole thing together. 0 squared plus y minus 7 squared. The next thing I'm going to do is I'm going to square both sides so I get rid of that nasty radical, because the opposite of taking the square root of something is squaring something. So I'm simply going to do y minus 3 squared is equal to, now instead of doing x minus 0 squared, why don't we just make that x squared plus y minus 7 times y minus 7, because that's what y minus 7 squared means. So far, so good? All right, so now it's just a lot of simplifying. So let's simplify on the left-hand side. Y minus 3 is the same thing as y minus 3 squared, y minus 3. So let's multiply this out, and we get y squared minus 6y plus 9 is equal to x squared plus y squared minus 14y plus 49. All I did was multiply them out, nothing fancy here. Now I'm going to bring the y's to one side, because if I want the equation, I want y equals, or f of x equals. So in this case, I'm going to move my y's to the left-hand side. So now the beautiful thing is I have a y squared here and a y squared here. These can cancel out. When you have the same thing on both sides, you can just cancel them out. All right, or you could subtract y squared from both sides and you'd see they go to 0. So I'm going to move this y, this 14y, over to this side. And I get 8y plus 9 is equal to x squared, these canceled, plus 49. So far I'm doing okay, and I want to solve for y, so that means I have to move the 9 over. And I get 8y, these cancel, is equal to x squared plus 40. And the last thing we're going to do is just divide both sides by 8. And I divide everything by 8 so I don't forget anything. So I get y equals, and I'm going to write it 1 over 8 x squared. You can write it as x squared divided by 8 plus 5. So there is the beautiful equation of the parabola that has a focus at 0, 7 and a directrix at the line y equals 3. Okay, we're going to do the same thing with exercise 3, except we're going to move that focus off of our y-axis. All right, so determine the equation of the parabola whose focus is the point 4, 1. And I've told you this before, I'm a very visual person. So you can always do this on a piece of scrap paper, or you can just, it depends on how artistic you are, if you're coordinated enough to be able to do it on just a piece of paper, and like I'm doing it here. All right, so it tells us here, determine the equation for the parabola. Whose focus? So this is what we're finding. Determine the equation of the parabola. Whose focus is the point 4, 1. 1, 2, 3, 4, 1. So this is my focus 4, 1. And whose directrix is the horizontal line y equals -3. Okay, 1, 2, 3. So y equals negative 3 is going to be this line down here. All right, and then it says first draw a diagram. So that's what I always do. That shows the parabola. Then carefully use the distance formula to derive the equation, just like we did in the last one. So we're going to, remember, this one also is going to open up because it's going to wrap around the focus. So if I look here, from my directrix, I have 1, 2, 3, 4 units up from one to the other. So that means that my focus, my vertex has to be here. So the vertex is 4, negative 1. And again, it's kind of close, so this is going to be a wide parabola. It's not really drawn to scale, but I'm okay with that. So pick a point. Doesn't matter where you pick your point. So let's pick a point right here. We're going to pick that point, x, y. I kind of like doing it this way because this way I can see what my distance is. So again, the distance from the focus to my point has to be the same as the point to the directrix, the vertical distance. Now, can you figure out what that vertical distance is going to be? Well, I know my y that's right here is from here to here. But I want to know what it's going to be from here to here. So, can you figure it out? What is the distance between the x-axis and the directrix? Hopefully you're realizing it. Well, this is a 3. This purple line here is y. This part here is y. So my left-hand side from my point to my directrix this time is going to be y plus 3 squared is equal to, those 2 points again were xy and 4, 1. So this is going to be the same thing. It's really just going to make my multiplying a little bit more complicated. So I'm going to do x minus 4 squared plus y minus 1 squared. So and now I'm going to, oh, I squared both sides already. No, I'm not supposed to do that. All right, so I'm sorry about that. I'm not squaring both sides yet. So it's the distance from the point to the directrix. So there, that's that vertical distance. That's the x plus 3. Now we square both sides. So sorry about that. So y plus 3 is equal to x minus 4 squared plus y minus 1 squared. Now, if you wanted to write it down with the squared like I did, you just wouldn't put the radical on the right-hand side. We all understand that, hopefully. So what do we have? Now this time I forgot to square both sides. Oh my gosh. Okay, so what does this mean? I'm going to have y plus 3 times y plus 3 is equal to x minus 4 times x minus 4 plus y minus 1 times y minus 1. Okay, so now what do we, now let's multiply it all out. So what do we get? We get y squared plus 6y plus 9 is equal to x squared minus 8x plus 16 plus y squared minus 2y plus 1. Just making sure my numbers look right, which they do. All right, so let's do some canceling and combining and flipping. And so the y's go out. They're on both sides. So I have 6y plus 9 is equal to x squared minus 8x. And now we can combine some like terms here. All right, minus 2y plus 17. And now we're going to take this y, I'm going to move this y over here, add 2y to both sides, and I get 8y plus 9 is equal to x squared minus 8x. These canceled out, plus 17. Now we're solving this for y, right? So that means we want to move this over. I have to keep reminding myself, just like you do, what we're doing. So I get 8y is equal to x squared minus 8x plus 8. And now divide everything by 8, and y is equal to 1 over 8 x squared minus x plus 1. There is my lovely equation. These are kind of fun. I like these. So your 611 classwork, some of you didn't get to that because we did the live lesson in class, so you can spend some time practicing this with that classwork. This will be on your test, so please make sure you're reviewing it. And until next time, you make good choices. I hope so.